So today we're talking about two big things in 3.8. We're talking about functions and relations. Within functions specifically, we're talking about domain today. And so that's like if you graph a function, what are all the values that x can be? X is going to be equal to all real numbers. X could be greater than or equal to 7. When you graph it, it's easy to see what the domain is, but we're just going to be given the functions, and so we have to figure out what to do from there. So let's go ahead and move into our first example. Find the domain of this function right here. This is a square root function, and so you have to think about the square root and what can go underneath it. So if you think really hard, you can take the square root of any positive number. You can take the square root of 0. But if you try to take the square root of a negative number, your calculator's going to go crazy. The square root of a negative number is an imaginary number, and we don't know what to do with that yet. So you can't take the square root of a negative number. So the smallest number that can be underneath this radical, the smallest number that x can be, is 0. So what we're going to do is set what's under the radical equal to 0 and figure out just exactly what x can be so that the number that ends up under the radical is 0. So I subtract 1 from both sides. I divide both sides by 3. So the smallest number that x can be is -3. So when this comes to domain, for our domain, x can be -3, but it would like to be greater than or equal to. Oops, I mean -1/3, not -3. So the domain of a radical or a square root function is always going to be x is greater than or equal to something, whatever made the underneath the radical 0. And so to figure out the domain of a square root function, you just set it all equal to 0 and solve. So the domain is x is greater than or equal to -1/3. About the domain of a quadratic. Well, this is on the bottom, and if you think about it, the number on the bottom can be positive, the number down here can be negative, but can the number down here be 0? No, x cannot be 0. So I need to figure out what numbers I would plug in for x in order for the denominator to end up being 0. In order to do that, I have to factor this. Hopefully we remember how to do that from algebra. So this is x squared plus x minus 6. I know that to get x squared, those first two guys need to be just x. And then this is a -6. So what multiplies to give me a -6 but adds to give me a +1? That would be a +3 and a -2. So looking at this, if I was to plug -3 in for x, that would give me 0. So I know x cannot be -3 because that would give me a 0 in the denominator. And this guy here, if I was to plug 2 in for x, I would get 0. So x can also not be 2. So the domain of this function has to deal with the denominator being 0 or not being 0. So for this domain, x can be every single number except for -3 and 2. So the domain of this function is x is not equal to -3 and 2. This example for today is function notation, finding the indicated values. So it says I have an f of x function right here that says x squared minus 1, and I have a g of x function that is 1 minus 2x. I want to know what f of g of -2 is. Now this looks crazy, but always start from the inside and break your way out. It's like this -2 is trying to break out of jail. So we're going to start with that -2 and keep building out until we've discovered what f of g of -2 is. So I'm going to start with the beginning. It says g of -2. So I want to look at this g of x function. G of x is equal to 1 minus 2x. And it says g of -2. Well, think about it. If I replace this x with -2, I got to replace this x with -2. So g of -2 is equal to negative 2 times negative 2 is a positive 4. And so g of negative 2 is 5. We just figured that out. So now, if I was talking about f of g of negative 2, and f is x squared minus 1, well, we figured out that g of negative 2 is 5. So I'm really taking f of 5 is equal to x squared minus 1. And remember, this is really x, so I need to plug x in, or 5 in for the x over here. So f of 5 is equal to 5 squared minus 1. F of 5 is equal to 25 minus 1. So f of 5 is equal to 24. And so we just figured out that whole thing. We just realized that f of g of negative 2 is equal to, g of negative 2 was 5, and then when we plugged g, or f of g of negative 2 into the f, we solve, and we got that this whole thing right here is 24. So you're starting from the middle and you're just breaking your way out. This guy on your own. It's the same f of x function and the same g of x function, but now I want you to find g of f of negative 2. So start with f of negative 2 and then work your way out. Use that answer to find the g of f of negative 2. Good luck.